Dear friends, welcome to another session of chemistry. It is on organic chemistry. More precisely, we will discuss about polymers. Polymerization, the process by which relatively smaller molecules link together to form larger molecules, is known as polymerization. Monomers, smaller molecules that link together to form a large molecule, are known as monomers. And what is polymers? The larger molecules that are formed by the linking of small molecule, that is linking of monomers, are called polymers. Polyethylene. When ethene is subjected to very high pressure at 120 degrees Celsius, it undergoes polymerization to produce polyethylene. The double bond in between the carbon-carbon atoms breaks easily, and the monomer ethene joins with another monomer ethene, and this process continues until a very huge molecule of polyethylene is produced. The polyethylene is a macromolecule. Polyethylene or polyethylene. Under suitable conditions, molecules of ethene join together to form large molecules as shown below. The compound thus formed is known as polyethylene, commonly known as polyethylene. Ethene is a monomer and polyethylene is a polymer. Polyethylene is formed by the addition of a large number of molecules of ethene. This type of polymerization, in which a large number of monomers just add together to form the polymer, is known as addition polymerization. Another important polymer which you need to know is polyvinyl chloride, commonly known as PVC. PVC is formed by the addition polymerization of vinyl chloride. Vinyl chloride is chloroethene. And when many monomers of vinyl chloride, that is chloroethene, are joined together, it produces polyvinyl chloride. Similarly, polypropene, polytetrafluoroethene, PTFE, etc. can be manufactured. These are other examples of polymers formed by the addition polymerization. Another example here is butane. We must adjust it in the form of the monomer of ethene, and the double bond will break so that the monomers of butane join together to produce a very big molecule known as macromolecule. Actually, this type of large molecule are formed by the linking of small units are known as macromolecule. Condensation polymerization. Condensation polymerization is a type of polymerization in which simple molecules like water, methanol, ammonia, etc. are eliminated. For example, ethanoic acid reacts with ethanol producing ethyl ethanoate and water, where the ethanol react with the ethanoic acid, the OH group from the ethanoic acid and the H from the ethanol combines to form water, and the remaining compound is ethyl ethanoate. This type of reaction is known as esterification reaction because ethyl ethanoate is an ester. And you should remember that esters have sweet smell. In the above reaction, a water molecule is eliminated when the two molecules join together. Therefore, it is an example of condensation reaction. Condensation polymerization. Here, observe well, a similar reaction occurs when two compounds are shown below react. There is a diol and a dicarboxylic acid which is reacting here. The hydrogen from the diol and the OH group from the carboxylic acid react to produce a compound. Moreover, this compound can further react with another similar compound, and this will produce the compound below and water. If this continues, a macromolecule will be produced. This process of adding together small molecules with the elimination of water molecule can continue. Therefore, a very huge molecule known as macromolecule will be formed. The final product will have the structure as shown below, and this will continue on. Therefore, this compound is an example of a polyester. Why a polyester? Because it contains ester linkage. C double bond OO is ester linkage, and this polyester is known as pteryline. The structure of pteryline can also be represented as follows, where the green rectangle stands for the group of C6H4 and the pink rectangle stands for the C2H4 group. Or it can be reversed. The pink can stand for C6H4 group, or green can stand for C2H4 group. So you must remember to put the key, whether it is green, pink, red, blue, yellow, any color can be the rectangle, or it can be a shaded rectangle or a striped rectangle or clear rectangle, but the key is important. You should remember that in between the carbon C double bond OO group, there should be the C6H4 group, whereas in between the OO group, there should be the C2H4 group. Nylon is another macromolecule produced by the process of condensation polymerization. One type of nylon, 6-6, is made from two compounds, that is hexane dioic acid and 1,6-diamino hexane. Both of them react together by condensation polymerization, that is, there is removal of water molecule, where the hydrogen from the amine group and the OH group from the carboxylic group react to produce water, and a huge molecule is produced. When similar compounds react together, a very big molecule will be produced and this reaction continues. The compounds keep on reacting. At the end, acid molecule will react, followed by amine molecule. With the elimination of water molecule, this will continue until very large molecules are formed. The compound thus formed is a polyamide. Why polyamide? Because it contains a peptide bond or amide bond. And this can be represented as follows, where the green rectangle represents the CH2 4' group and the red rectangle stands for the CH2 6' group, and the CH2 4' is found in between the CO group and the CH2 6' group is found in between the NH group, that is amine group, and the other one is a carboxylic group. Natural polymers. Protein consists of macromolecules having structure similar to that of nylon, but with different units. When proteins are boiled with dilute acid, proteins are hydrolyzed to amino acid. When it is boiled with aqueous sodium hydroxide, they form sodium salt of amino acids. Fats consist of macromolecule with a structure similar to that of pterylene. They react with aqueous sodium hydroxide to produce soap and glycerol. Soap are sodium salts of higher fatty acid. Sodium stearate is an example of soap. Its formula is C17H35COONA. And another example of natural polymer is carbohydrate. There are various forms of carbohydrates. Starch and cellulose are carbohydrates. The starch and cellulose are carbohydrates consisting of macromolecules. This means that many monomers have joined together to form starch and cellulose. These molecules are formed by the condensation polymerization of sugar molecules are shown below. The sugar molecule consists of OH group. The OH group in between the sugar molecules react in such a way that a water molecule is produced and the various monomers are joined by the oxygen atom in between them. These molecules consist of a large number of sugar units joined by oxygen atoms are shown below. When they are boiled with dilute acid, starch is hydrolyzed to sugars. When boiled with dilute acid, starch is hydrolyzed to sugars. The molecule of cellulose also can be represented by the formula C6H10O5. The molecules are more complex than those of starch. Artificial silks like crayon and cellophane are manufactured from cellulose. We have come to the end of this session. I hope that you have understood the various concepts on polymerization, polymers, and their reactions, more precisely on the formation of the various polymers. With a hope to see you in our next session. Goodbye. Thank you.